Hello everyone and welcome. In this video we're going to be taking a look at an advanced Linux privilege escalation technique, or vulnerability rather. And in this particular case we're exploring shared library injection, which is it's a technique that again not a lot of people factor in or actually consider, but I think is quite interesting to explore, and it builds on what we covered in the previous videos when talking about pseudo privileges, or rather misconfigured pseudo privileges. But with that being said, we firstly need to understand a couple of things. So firstly, what is a shared library in Linux? Well, in Linux, a shared library is sort of the equivalent of a DLL in Windows. It's typically, you'll typically see shared libraries or shared objects, as they're colloquially called, with a .so extension. So just think of them as DLLs for Linux, and it's pretty much a file just like DLLs that contains code and data that can be loaded by multiple processes at runtime. And this particular technique is very similar to the Windows privilege escalation technique that we took a look at, called DLL hijacking, with a few differences, but in essence, we're pretty much leveraging shared objects, which again are just like DLLs, to elevate our privileges. So shared libraries or shared objects in Linux allow code to be modular, reusable, and reduce memory usage, as multiple processes can use the same shared code, or the shared library or shared object, as it's pretty much called. But hopefully that makes sense. Now, in terms of shared library or shared object injection, it pretty much involves injecting a custom shared library or object into a running process to execute arbitrary code and manipulate the process's behavior. And this particular technique can be used for various purposes, such as debugging, monitoring, or in the context of privilege escalation, pretty much allowing us to elevate our privileges. Now, in terms of how it works, with relation to privilege escalation, we first need to identify a target process. And this, involves identifying processes with elevated privileges, or alternatively, as we'll be looking at in the lab, finding specific pseudo privileges that allow us to execute specific binaries or services with root privileges, and consequently leveraging the preload functionality to load in a malicious shared object. Which then brings us to the second point, where we need to create a malicious shared library or object that again does what we want it to do. And in our case, it could be as simple as launching a bash shell as the root user, so on and so forth. But the attacker creates a shared library or object containing the code they wish to execute, and this code can include arbitrary payloads, backdoors, or other malicious commands or activities designed to achieve privilege escalation. And then finally, we inject the shared library into the target process. And there's several techniques that we can use to do this. The first, and the one that's going to be applicable to this lab, is the LD preload technique. And this is an environment variable that specifies a shared library to be loaded before any other libraries when executing a service or application. And by setting this variable, an attacker can preload a malicious shared library into a process, and we then have process control, or ptrace. So the ptrace system call allows a process to control another process, typically used for debugging. And attackers can use ptrace to inject code into a running process, causing it to load a malicious shared library or object. With that being said, let's get started with the practical demonstration section of this video. So this video has a lab associated with it, and it's going to be the lab just below this video. And again, similar to the previous labs within this section, you'll be provided with access to the Linux system, where we've already obtained initial access, and we have access to the low or standard user account called student, and we're going to be working from that point. So I'm going to fire up the lab, and I'll see you there in a couple of seconds. All right, so I'm currently within the lab environment, and you can see we have access as the student user. And the first thing I'm going to do is check for some sudo privileges associated with this account. And right over here, we can see that in terms of the environment variables, we have the ability to set or to use the LD preload environment variable. And we can also see that the student or the user student can run the following commands. And in this case, we can start up Apache 2, the Apache 2 web server, with root privileges without providing a password. So we can pretty much leverage this service here to execute our own shared object because we can set we have the ability to set the LD preload environment variable where we can specify a specific shared object, and we can pretty much specify whichever one we want. So we can actually create our own shared object, and it's fairly simple to do. Of course, it's going to really depend on what you're trying to achieve. In our case, we're just going to get it to launch a Bourne shell, and we're then going to use it or set the environment variable and execute Apache there. So first things first, let's just use Vim to create our shared object, and we'll create it in C, and then we'll compile it into a binary or into a shared object, as it were. So what we'll do is we will say we'll just say include the standard stdio.h, and then we'll also include sys types.h, and we'll also include the standard library, so include stdlib.h. Let me just make sure I correct that so we don't get any errors. We will then create the main function, so we'll just say void, actually we'll just call this one not main, but we'll just say void init, so pretty much specifying what we want it to do. And right over here, for the love of God, if I can type correctly, but there we are. We're not returning anything, but the first thing we want to do is say unset environment variable, and in this case we're going to say the environment variable we want to unset is preload, and we will then say set GID to the root or the group ID of the root group, which is just going to be 0 in Linux, and then set use ID to the same 0, so the use ID of the root user, which is always 0, and then we'll say system, and we can execute bin or the Bourne shell. We can also execute bash, but this should work. So including stdio.h, systypes, standard library, and yeah, that looks about right. So now we would obviously need to compile it with something like GCC, and actually hold on, I forgot to specify a space here. And yeah, that looks about right, and I forgot to add in the semicolon here, so always good to read through your code. But now let me cat out shell.c. Yeah, that looks about right. So we can now say, we can now compile it with GCC. So I'll say GCC fpic shared, and then output is going to be shell.shared object or SO, and the file we want to compile is shell.c, and we'll just specify the no start files flag here. Let me again make sure I spell that correctly. So no start files, and we hit enter. Don't worry if you get any issues or any errors, but there we are. We have the shared object right over there. Now what we want to do, because we have the privilege, the sudo privilege for the student user, we can leverage that particular permission, or we can use sudo to change the value of LD preload or the LD preload environment variable to our own path that contains our own shared object, and we can then execute the Apache 2 program or the Apache 2 service, as it were, with sudo privileges, and consequently this will lead to the execution of the code written in the init function of the shell, and will provide us with an elevated shell. So we'd essentially need to say sudo ld preload, and that's going to be equal to home student, pretty much the path where the shared object that we created is saved. So shell.so, and then Apache 2, hit enter, and if we say ID, there we are, we've elevated our privileges to root, and that is pretty much shared object injection in a nutshell. And just to summarize, again, to go over what we had done, let me go ahead and list out the privileges, the sudo privileges for the student user. So you can see that in here we have this the ld preload environment variable set, but what this means is that firstly, we can see we can run Apache 2 without providing or as root without providing any password, and we also have the specification that allows us to specify the ld preload or set the ld preload environment variable. And we pretty much created a shared object that pretty much executed the Bourne shell or bin sh as root, and we pretty much were able to do that by launching or running the the ld preload command, or by setting the environment variable with sudo and also executing Apache 2. And there we are. So that brings us to the end of the practical demonstration section of this video.